So let's get into it. Artificial intelligence. Well, in the end of the day, artificial intelligence is nothing but complex data management, right? But yet it will really bring the next big evolution to the way we handle and we interact with data these days. So we've had the classic data management in the past. We've seen our Excel wizards doing crazy stuff with macros. We then saw the kind of RPA revolution where process work streams were standardized and then automated in data management. So now artificial intelligence is really enabling us to bring that next level of complexity to the data handling. And obviously these days we have the computational power to process that data. So for TCI and for RLE, we decided to form this partnership to dig a little deeper into process management applications and bring AI to the process of product development, mainly in engineering. So we aim to become the competence leader in applying AI in engineering. And why I'm corroborating the application rather than the base development, you probably see that in a minute. So let me very quickly talk about the partners for this specific tool that we're going to present as a use case today. As mentioned before, it's just an example. There are other applications, so it's really important that we do that transfer of the idea behind to any other process in product development, right? So RLE originating from total vehicle development. So we've been in automotive for the last 20 odd years. We've really started with, designing components and then gradually evolving into a total vehicle developer. So we do everything that is related to vehicle development other than producing parts. TCI specializing in transformation, and as part of this transformation, transforming processes and data sets with the application or with the use of AI. And then for this specific use case, we've had Humanize as one of our partners. Humanize is a startup from Berlin, specializing in taking off the shelf agent or bot technology, AI bots, and tailoring, customizing them to the specific need of a client or a specific process or endeavor. All right, so AI in automotive product development. If we have a look at the top 10 automotive industry trends, you see about 7% of these trends is what people call artificial intelligence. However, if you take a closer look, there's AI in most of the other fields as well, right? So without AI, there won't be any autonomous driving. You need visual recognition, you need quick data processing, you need decision making of the algorithms. This is all, in the widest sense, AI application. The same is true for the connectivity applications that are out there. We have the big data and data analytics that is also required to empower connectivity topics, to empower autonomous vehicles. So in the end of the day, if we have a look at these trends, artificial intelligence is not just about the 7%. Artificial intelligence is actually applied in most of the fields that we see in the top 10 automotive industry trends. The biggest by far is ADAS, so anything related to autonomous driving, and the personal assistance or driver control or interaction with the passengers. These are the big fields, and this is what most of the OEMs, most of the engineering suppliers will focus on and will understand if they talk about AI in automotive and AI application in the vehicle. Obviously, the vehicle and its mobility environment, that's one part of the story. The development and the production is the other part of the story. So we see a lot of AI application when it comes to manufacturing, when it comes to smart robotics. We have lights out factories these days, so completely autonomously acting production lines. empowered by artificial intelligence. The after-sales sector, so everything that happens in the life of a vehicle once the product has been sold, is very much AI powered these days when it comes to automatic insurance processing, when it comes to damage recognition, hail damage recognition control, again, visual recognition. There are a lot of AI applications we find those days. Then obviously anything regarding quality control, visual inspections, where you'd still use human auditors a couple of years ago. This is more and more replaced by, again, visual recognition, video control. You find supply chain optimization empowered by smart algorithms. And obviously there's also the hardcore engineering, so to say. So there is automated design engineering these days. There is AI powered topology optimization. And if you look a little bit into the process side, you'll find a lot of, well, AI applications, early AI applications driven by requirements engineering. Why is that? Requirements are standards. Standards can easily be translated into data, and whatever is translated, enabled, and fueled by data can then be further automated and automated by artificial intelligence applications. So overall, what I want to say here is if you check all of these trends in the automotive industry, and if you see the big technology or algorithm driven fields in the world of automotive, there's AI in all of these fields. And the one thing we wanted to focus on is actually the process side, which is still some sort of an uncovered niche. What is the challenge with these AI applications? Well, most of these applications are still very case specific. And so they are complex. They are complex to define, they are complex to implement, and the environment in which they are embedded is complex as well. So it only works if you have big data. If you have big data, you can generate big value. But what if you're not an OEM, if you're not the automotive manufacturer? How can you use AI? How can you apply AI at an acceptable money for value level? Usually these applications also require a lot of data engineering. So you need someone to really define all the baselines, the fundamentals to make your data processing efficient and with a low or the least acceptable failure rate. Usually you don't get plug and play solutions, so there's still a lot of tailoring involved, and the more complex the solution, the more complex the data environment in which your AI solution is embedded, the more customizing is obviously required. As with any major change and most of the digitalization solutions we've seen in the past, AI solutions require transformation management and trust building. There's still a lot of hesitance amongst users, particularly the development of complex products involves a lot of different stakeholder groups, a lot of different interests, a lot of different priorities. So it's a lot of stakeholder groups that a transformation manager has to work with, where trust building needs to be ensured. So again, the implementation as such comes with its own complexity. Quite often it's customer specific. So you spend a lot of time, you spend a lot of resource to create a specific solution for a specific customer within their data environment. But how can you scale this? How can you bring that into a wider market? So the question that we ask ourselves is, where are the quick wins? All of that AI applications we've seen so far, and considering the fields I've mentioned before, that is all valuable, right? And it offers a lot of benefits to the big manufacturers, the big companies. However, where are the quick wins for smaller companies, for engineering service providers, and where can we also enable startups in the world of mobility to capitalize on quick wins by implementing AI? Well, we thought the easiest way and the biggest value that can be easily and quickly achieved is probably by facilitating user interaction with data. And this is why we decided to focus on language models and to use large language models as a baseline for a user interaction model. So what do we mean by that? We want to create agents, bots that enable users to interact with the data, but also with the tools. So you have the classic data analysis, you can easily create reports, but we also want the user to be able to manage data without necessarily being a systems expert. We want a tool that is capable of providing recommendations for decision making, yet it always needs to acknowledge the human in the loop. So we're not aiming to create the supercomputer that gives you the best solution, because best solution in complex product development environments is, again, difficult to define. So we only want the tool to provide recommendations. The user always needs to be the party that basically takes the decision, depending on wherever they put the priorities. Is it process efficiency? Is it cost? Is it timing? Is it resource utilization? Whatever it may be. We want users to interact with the data and with the system without being the system expert. And if we take that a step further, we probably can enable users to interact with data and to interact with the systems without even being the domain expert, as long as the tool that we're implementing can, first of all, provide recommendations, but also show implications of decisions made. That's obviously subject to the case, but that's part of our concept vision. We want the user to also define and implement further functionality without having any programming skills. So if we consider this data analysis and report creation part, most of you probably know Power BI, right? But still, Power BI requires quite a significant level of understanding of what you can do with Power BI, how to get it to work, how to create your user interface, and so on and so on and so on. Using language models, using agents, you can use your natural language to define your requirements and to make a bot act the way you want. So consequently, we want any user to be able to define and implement additional functionality. So it's not just about the data analysis, and it's not about only being able to manipulate the data. Our wider vision wants the user to be able to define further functionality by using their natural language and prompting functionality to the agent to create further features for the tool, further features with the bot. And so all of that, we've proven that, and we'll show you in a second, can be built with existing off-the-shelf functionality and existing data repositories. It's really just a question of combining everything and then putting it all together in the right way and in a quick way for the user to implement as quickly as possible. So let's get a little deeper into our use case before Oleg will show you the live demo. What we focused on is DVP, so the design verification process. Why? Because we have a lot of stakeholders involved in prototype management in the automotive industry. We have a lot of complex data that needs to be handled. We have a lot of requirements from all different sorts of functions and stakeholder groups that need to be analyzed and merged, and that all need to be turned into a plan. So we thought, well, that's one of the more complex sub-processes where easy data management and analysis of data could be quite helpful. And it's certainly the phase during vehicle development that takes a majority of the product development time and a major chunk of the costs of the budget. So wherever we are able to improve, whether it's on the cost side, whether it's on the timing side, it will be a major saving for the automotive manufacturer. And consequently, wherever we can improve time to market, or money spent, it will provide tremendous value to the customer, and consequently, it will help with their willingness to pay for the service and implement the solution. So if we have a little look into the DVP process, why is that not working now? Okay, I'll just quickly jump there. Sorry about that. Oh, I lost my process. Okay, then I need to just zoom in here. That's okay. So if we have a look at the DVP process, it's basically three phases, three sections, right? The first one is about defining what needs to be tested. Is it the overall product, the vehicle? Is it a system or subsystem? Let's say a door or a combustion engine as a system as such, or is it a specific component? Let's say a door handle, for example. So once we've defined what needs to be tested, we need to combine the components with specific testing requirements. How is it tested? Whatever we want to find out there, whatever we want to test, and which resources are required to enable us to do this test. And this is then all translated into a test plan, which kind of defines this a third phase of the prototype testing process. Now, the test plan that tells us what needs to be tested when. Does it need to be tested on a full vehicle? Does it need to be tested on a rig? Does it need to be tested in the virtual environment? Who needs to test it? So who has access to the vehicle, the rig, whatever it may be? How is it tested? When is it tested? Consequently, it also includes things like a build plan, build sequence for the prototype fleet. When do I build which vehicle to enable test ABC at a certain defined point in time? And this is where we focused on for the DVP Assist, because we thought that's where you have most of the user interaction. That's where you have a lot of change coming on, because things never turn out the way they are usually planned. Tests fail, you need to reallocate tests to other vehicles, you need to redo tests, you want to improve your prototype fleet volume, i.e. reducing the number of cars used, and so on and so on and so on. So we thought once that initial plan is up and running, somebody needs to interact with that data, somebody needs to manage that plan, somebody needs to manage change. And this is why we then decided to look into the DVP usage phase and create an agent that enables the DVP manager and other stakeholders involved to interact with that data, to retrieve any reports, whatever they may require at that point in time, and also to juggle with the data, build scenarios, and get recommendations from the tool. And yeah, I think it's time to hand over to Oleg to give you a little bit of live demonstration into what we've created there, how this whole thing works. Again, let me just corroborate again, it's not just about the prototype testing, right? So what we are going to show you here can be applied to any sort of process. That's the underlying idea here. And DVP is simply our use case for today. But yeah, over to Oleg now. Thank you.
Thank you, Florian.
Just before you make a start, Oleg, just a quick one. Thank you for that, Florian. It was really interesting. I'm sure that there's loads of little nuggets that people can take away from there. Just if anyone has any questions in terms of what Florian's just presented, drop them in the chat and we'll be sure to get those answered towards the end of the process. So anyone at any moment, if you have any questions, just drop them in the chat and I'll make a list of them to answer. For both Florian and Oleg to answer. Great, passing over to you, Oleg.
Okay, thanks. So yeah, also hi from my end. Exactly like Florian said, yeah, we had to take the decision which process are we going to enrich with some AI capability, right? Because like he also said, it's not about the DVP process itself. It's more about, okay, we're in the engineering field. There are many processes. They're mostly complex, right? There is a high potential to enrich them or enhance them with AI, but how could we do that. And then that's why we chose this DVP process, right? And we came up with something that I'm going to show you. 1 second. Oh, do you see?
Yeah, we can see.
All right. All right. So we came up with just let me close that here. Okay. And then, all right. We came up with a dashboard, right? So this basically shows from the perspective of a DVP manager or test manager, so to say, you would have the DVP plan. You can see the different tabs. This is then basically the use cases that we planned in. So the test plan creation, fleet plan generation, build plan creation, right? And then like in a typical dashboard, you have KPIs, like the basic KPIs that you need to know from the first side, right? Then we talked about different test vehicles, right? The test vehicles on the left side, right? And then you have the Gantt chart, which is showing when they are timed, right? So you have the different tabs. And then we also have different other dashboards like test plan timing and so on and so forth. What becomes interesting here, we have some, we thought about some notifications, right? Which are made by the system. For example, they make you aware that a test failed, or maybe they make you aware of a risk because of a high number in a certain time, or they make you a suggestion, right? So we also have this thing here, add filter, right? Like a basic dashboard. The only difference here now is that we actually manipulate the filters, for example, with the query window. We have the chat window on the right side, right? So I would like set this filter here. Then I would expect the system to filter. The filter is set, I see that. And that's basically an assistant that sets me the filter, right? Adjusts me the dashboard, right? And then I have the filter view. And I also, again, I had to preload the queries here in this app because we still experience, we had one sprint, like we built this in like 2 weeks or so. And like there are still some performance issues, right? But I think you're aware of that if you work in software development. So anyways, so the next chat I already prepared, where I asked, for example, which tests are planned for durability. Durability is the type of test in winter 2025, right? So then the question is, normally a dumb chatbot would not understand winter. So I would expect this one now, because we work also with the GPT-4 25K mode. I would expect it to understand what winter is, and then it gives me this report, right? So these tests are planned. Oh, okay, and this is, okay. Then I show you the next one. So imagine the scenario. I'm the test manager, right? And then I get a call. So the snow ingress test in Sweden failed with this vehicle, right? And I let the assistant know that, and this and ask if there is another, because not every vehicle is suitable for a winter test, right? So I wanted to look into the database and then to suggest me a vehicle, and it does exactly that. So, and now I can even go and say, okay, plan this test. And now I would expect the number of total tests here to go up. But as you see, we sometimes still have waiting times, right? But in the background, it creates a query or some database processing and adds the tests, writes them into the database, and adjusts everything on the dashboard. So just give me 1 second. Oh, well, we can actually come back here in a second. All right. Did it? Okay. Let me just come back to that. So in another scenario, for example, I say, okay, check all the tests for next year. Okay. Check which circumstances might be critical and check the risks. Are the calendar weeks that show more risks than others? If yes, recommend what to do. So in here, in this case, first of all, what is risk, right? And it comes up with actually plausible risk factors, which is then test weight, complexity, factor budgets, and this is all in the database, right? And then it gives me out a couple tests, right? Then it gives me, then it assesses the risk, and then I also wanted to know which weeks, right, might be the most critical, and then this is now interesting, right? Also, the Jabberbot might have offline and online synchronization. And I didn't know what the Jabberbot is, but this is like typical hallucination, right? The Jabberbot is some multifunctional robot for kids, right? Okay, but yeah, that also can happen. I just wanted to show you that. So, and then I say, okay, never mind, proceed, right? And then we calculate the risk scores for weeks, and then basically it gives me a report. Right, so it is actually intelligent. Sometimes it hallucinates. Now let's go back here, okay? And it actually wrote the test into the database. If you remember, we had 189 tests, right? Now we have an additional test, it planned it with the budget and everything, right? And manipulated the data in the database, right? So yeah, that's a demo. Let me maybe, can we switch to the presentation again? I would like to lose a couple words also on our process and what we learned from this first sprint. Is there?
Does Florian need to share the screen for that again, or do you have access to it, Oleg?
No. Florian,
Nope,
can you share?
I need to, but you need to allow me, Finley.
Okay.
But
Cool.
yeah, I think I just got it. There we go.
Perfect.
Okay. So yeah, what can I say to that? So this is like the build-up, right? How it comes together. That's something like the design. So we have the user interface, what you saw, and then we have a couple of modules because the queries need to be processed. Then there's some retrieval. We need to work, as we work with the OpenAI assistant endpoint, right? We work with some tools, and then we decided to have PostgreSQL database, right? This is a very basic setup. We just wanted to keep it easy. Can we move on to the next one, maybe? So, and then why actually AI? Someone would ask, why would we develop that with a GPT endpoint? And yeah, my opinion, right? The benefit here is like that we have two capabilities coming together, and that is the data insights and also the automation, right? So it's just a new way how you saw, like you saw, to explore the data and then also to manipulate the data. You sometimes you even get intelligent suggestions for the next steps, right? And then you can also you also don't need to write the SQL queries by yourself anymore, or you don't have to ask a colleague, right, to write the SQL queries for you if you have a SQL database, for example. And then you can actually think about creating reports and just, you know, just export them or let them send to you whenever needed. You can go to the next one. So, okay, but then to be honest, we also see some limitations. You probably also saw that, right? And the biggest limitations from my end, or to my opinion, is first of all, the database management, right? Because right now it's just a very stupid SQL database. If you want to build a real product, you would need to think about security, compliance, user access, and stuff. And then also, you cannot just let the assistant use the bare database because it wouldn't understand anything. Like in a real database, it wouldn't understand anything, right? So you would need a description of the database, and it would also need to be clean. So you need to define a whole process around that. That's a lot of effort, right? So, and then you experience some performance issues, like you saw, for example, the waiting times. There are techniques to you know, approach that, but still, someone has to do it, right? So, and then the hallucination, we just saw it. Also, what you can think about here is some active reg techniques, or you can just implement some human feedback loop or some reinforcement learning. But I mean, it just becomes more and more complex, but that's definitely a challenge. And then the functionality right now, how it is, right? If you're a test manager, you would probably say it's strongly limited. Yes, it is, right? But that's the art behind that, to go to drill it down to the most basic functionality, right? And then scale it up from there. We can go to the next one. So yeah, and then the broader picture of we want to, or how we want to improve that thing what we have here now is, first of all, and that doesn't only account for the DVP assist, that accounts also for further applications that we're gonna go. The next step for the next sprint would be to build a dashboard, right? Then to define some user KPI or KPIs like user satisfaction and, you know, accuracy, error rates and stuff like what you have for LLMs, but not only. And then you would also collect not only queries, but the whole conversations, right? Because that's super crucial to collect that and build on that, and then also implement them into a feedback loop. And then, of course, you would need to test how actually the solution like works, or when it's thrown out there and used by like a bunch of people. Can we go to the next one? So, okay. While developing that, I just want to tell you a couple lessons learned, or a couple challenges that we faced, but then also the breakthrough moments. So to be very honest, we underestimated the process in the beginning, right? Because we actually thought, okay, there are documents, you just throw them in as a context, and then the model deals with that. No, it was not so easy. To first of all understand the process was super hard, and we were lucky that our subject matter expert was really working closely with us. Otherwise, it probably would have failed. So, and then another thing, what we didn't know, what for example, should we use a vector store? Should we go with a graph-based database, or should we go with a SQL database? Right? In the beginning, we couldn't decide. Maybe we go with everything, right? And then in the end, to come up with the SQL PostgreSQL, that decision we probably could have taken earlier, right? If we would have done it right. And then also, this whole process required just strong collaboration of every party. And then, you know, we didn't really have the framework for that at this point in time, right? Or not straight from the beginning. Could have done it differently. But then there were also some breakthrough moments, which was, for example, at some point we just ranked and prioritized the user stories, the features, and then it just, yeah, everything just went way easier. And then we came into this iterative testing and frequent feedback, situation. And then at some point we realized, okay, the more we define, right? So the less you really need to imagine, of course, right? The easier it became. But also because, yeah, that's not so easy, because these, language models have a certain undeterministic nature. It's not so easy to know exactly what you're doing, right? You need to do it, but you need to like be agile somehow in this regard. So, and that I just want to show you one working document on the next slide that we had, and really everybody contributed to this one, right? So that you know what I mean. We had the use case, and this is also what you saw in the app. You have the build plan creation, the test schedule, and so forth, then the description of the case, and then yeah, which kind of documents, what kind of information would be required by GPT, right? Or and then the database, which table, which field would have this information, right? And then the integration point, that's basically the instruction for the system, right? And because we also wanted to integrate this into a dashboard, that needs to come together with a KPI, and the KPI then with a dashboard again, right? So basically everything is defined, right? And not so many. So you basically don't have any questions anymore and then you can basically develop that, but still many things will not work. But it makes it more straightforward, I would say. Can we jump to the next one? So yeah, if you want just six takeaways. The left-hand side is the business takeaways, the right, the technical, right? So And I think for that accounts for all language model-based applications. Users just need to contribute and like proactively really support the development, but otherwise the development, I think, will in most cases fail. And then for that, you definitely need some, agile approach, and then really live it, not just only say, but really live it. And that also requires a lot of time by participants, right? And then especially if you develop that for clients, right? That's sometimes really hard to get. And on the technical side, it's just make sure you have the database, right? Where's the data coming from, and what is the process of cleaning it up? And the next one is, there's a lot of stuff coming out in terms of open source and cutting edge, right? And that's all good, but when you're dealing with client data and sensitive information, design documents and stuff, it's probably better to just work with your with the cloud provider that you have, right? Because you have a service level agreement there, and like makes it way easier to also argument that internally what you're building. But in the beginning, I think most of the solutions or rank-based solutions will probably not have the best performance or not the performance that many people will expect. But I think the improvement curve is very steep, and it gets better very quickly. So yeah, that's it for mine.
Perfect.
right.
Thank you for that, Oleg. Was both of you was able to share some really insightful stuff there. And I guess whilst we're waiting for people to type, if there is any questions for both Florian and Oleg at any given moment when they was obviously sharing some information to you guys, then please get those in the chat. I have prepared a couple of questions myself for both of you two, just to keep the interactive session going, so to say. And something that I'm always quite interested in asking, like everyone within my industry where I work in the AI space and talk to a lot of talented individuals day in, day out. I always like to keep ahead of the curve in terms of finding out what the next biggest thing is in AI and how people actually envision where it's going to go in the next coming years, because there's loads of interesting developments always coming out from it. Like large language models wasn't even really being spoken about 2 years ago, and now it's the next big thing, obviously, and a lot of companies are implementing it into their systems. So I think a really important question that I have for you guys, and something that will probably be quite insightful for the audience, would be like, how do you envision AI transforming the engineering industry over the next 5 years? And also, what do you feel are the key milestones for your organizations in this journey?
Maybe I take that one. It depends. I don't think there's a single answer, because AI, as I've just shown, we've different sorts of AI applications in different domains within the field of product development. And so obviously the entire ADAS topic will go beyond what we imagine today. So I absolutely believe we'll get to these level 5 autonomous cars, so 100% autonomously driving vehicles. So that will definitely push AI in the utilization of or operation of vehicles. That's the one big thing. I think there will be a lot of just highly powered data management, particularly when it comes to things such as logistics, supply chain, manufacturing, and also the after sales business. That's this second, third pillar that I was shown. Then obviously, if vehicles are autonomous, drivers and passengers need to spend their time somehow. So everything related to user interaction, passenger interaction, will also give that big push to AI. But the interesting thing from my point of view, and that's probably also because I have that background in program management, but for me, the interesting thing is, where will AI take us in terms of product data management and in terms of process data management, right? Because today we still have a lot of discussions, despite standardized processes whatsoever, we still have a lot of discussions on the how rather than the what. So we often have quite a good idea of where we want to get to, but because it's so complex, it's so many stakeholder groups involved, it's so many different work streams going on at the same time, it's very complex to realize these things. And you need a lot of workarounds and a couple of projects to learn and fail and improve and then finally succeed. And I think AI will really give a push to this, because particularly with the language models, as we've just shown, you enable the user to focus on the what. So what really gives me efficiencies? How can I improve my process? How can I, or what is the optimization potential that I can really capitalize on, without having to spend that much thought on how am I going to make that happen? And I think particularly on the process side of things, that will really give a push. And the beauty about these kind of automated, highly complex processes that are going on there, we will be able to ignore a little bit the situation of all of these multifaceted solution landscapes that we have out there, because hardly any of the OEMs have that single source of truth. It's a lot of systems, a lot of databases that are somewhat connected by process rather than by data logic. And I think yeah, AI can really provide that lever to bring a lot of efficiencies to that data lake that inevitably exists in any of these larger organizations.
Yeah, definitely. I think I agree with your points there. And I think what's really cool about AI as well, and why a lot of companies are now needing to implement it, is because ultimately it really makes processes a lot more simpler across the board. And also saves a ton of time with these processes, which is obviously fantastic, and that's great why that everyone's moving into this direction now. Nice, really good. Thanks for sharing some insight around those as well. I think it's definitely an interesting topic. I always like to talk about AI within sort of automotive development, and seeing how we're moving in terms of the testing side, also the validation. I think it's a very interesting topic for all. And yeah, I know, like I said to you guys, Florian and Oleg, before we started this, like, we had a lot of positive feedback from this talk, and I know there's a lot of people that want to hear the full recording. So yeah, I know there was a few latecomers that came in there, which I just admitted, you guys. Yeah, sorry, you're a little bit towards the end now, but I will be posting a full recording onto the YouTube channel. We'll also be making some small clips of like the interesting parts of the discussion from both Oleg and Florian. But Oleg and Florian, I'm really thankful for you guys coming on here. It was a great session, a lot of insightful information there for the audience. And yeah, hopefully we can run it again with you guys soon, once obviously you're further down the line with like the product development on the DVP Assist, or whether it be a new product as well.
All right, let's see. Yeah, thank you for having us, Finn. Really appreciate that. It was fun also preparing it. And thank you for everybody who listened in.
Yeah, thank you very much also from my side. Good session. And if there are any further questions down the line, you know how to reach out to us, and happy to help.
Cool. Perfect. Thanks, guys. I'm going to end the session now. And yeah, any other questions, feel free to reach out to any three of us. We'll be more than willing to sort of answer any questions. Perfect. Bye for now.
Thanks, everybody.
Bye for now. Take care.
Ciao.